Hey there, this is pages 9 and 10 in the Solutions Unit homework. This is net ionic equation practice. I'm going to do a couple of these on pages 9 and 10. The first one I'm going to do here, manganese 2 chloride plus ammonium carbonate yields manganese 2 carbonate plus ammonium chloride. So I need to write this as a balanced equation. So I just start pulling everything out. So I know manganese is Mn and chloride is Cl. Manganese is plus 2, so you crisscross those, and that would be manganese 2 chloride. Plus ammonium carbonate. Ammonium is the positive polyatomic ion, NH4 with a plus 1 charge. And carbonate is CO3, also polyatomic. So when you crisscross those oxidation numbers to make them subscripts, NH4, 2, CO3. Yields manganese 2 carbonate. So manganese is going to be 2 still, and carbonate's 2 still. So you won't get any subscripts at all on that manganese carbonate. Plus ammonium chloride. So I need to balance this equation. The ammonia and the chlorine both have a subscript of 2. So over here I need to make each of these a 2. So I'll just use a coefficient of 2 right there. And the equation's balanced. So write this, in order to write this as a total ionic, I first need to know if either one of these is my solid product. So I'll go back to my solubility rules. I find my carbonate first. So carbonate is right here. It's in the insoluble compounds. It says that carbonates are insoluble unless it's ammonium carbonate or an alkali metal cation with carbonate. Well, manganese is neither one of those, so this is going to be a solid. Ammonium is positive polyatomic, there it is, and it's always soluble with no exceptions, so I know that's going to be aqueous. I'll give that an AQ. So I start breaking up everything into its ions. So there's one manganese with a plus 2 charge, plus 2 chlorines with a minus 1 charge. Okay, that's how you break up the manganese and the chlorine. Plus, there's 2 ammoniums. So NH4, I'm sorry, 2 NH4s. Let me fix that. 2 NH4s with a plus 1 charge. Plus my carbonate, there's only one of those, CO3 with a minus 2 charge. Okay. So over here, the one thing you don't break apart is the solid product. So I'll leave manganese carbonate intact. And break up my ammonium and my chlorine. There's 2 ammoniums with a plus 1 charge, and 2 chlorines with a minus 1 charge. So I go back and forth on either side of my equation here, on either side of the arrow, and cross off the things that are the same. So is there a single manganese by itself over here? Nope. Manganese is bonded to carbonate over here. How about 2 chlorines with a negative charge? Yep, way down here. So those can be crossed off. They're the same on each side. Are there 2 ammoniums with a plus charge? Yep, right there. Cross that off. And carbonate is bonded to manganese, so there is not a single carbonate by itself. So my net ionic equation is what I have left over. Manganese plus 2 plus CO3 minus 2 yields manganese 2 carbonate. So there's your first one. On the back, I'm going to do number 10 because you also have to complete the equation. This is a double replacement reaction. So I'm going to write barium, Ba, nitrate. So barium has an oxidation number of plus 2 because it's in group 2. So barium nitrate, and nitrate is minus 1. So when I crisscross those, I'll have a subscript of 2 there for barium nitrate. That's how I write that formula. So ammonium phosphate plus ammonium, it's NH4, and again that's a plus 1 for that polyatomic ion. Phosphate is PO4, duh, with a -3 charge. So crisscross those, shouldn't have written that. Crisscross those, and that's my formula for ammonium phosphate. So in a double replacement reaction, remember I've taught you to take the positive ions in each one of these compounds and write them in the exact same spot over here so that you don't mix anything up. So I'll write barium, skip a little space, write my plus sign, and after the plus sign is ammonium. Then I swap the negative ions. That way nothing gets out of order. So barium phosphate and ammonium nitrate. Let's see, barium plus 2, phosphate minus 3. So we'll crisscross those, and we'll put a 3 there and a 2 there. And then ammonium's plus 1, nitrate's minus 1. So let's balance this equation. 1 barium, 3 bariums. Let me start with a coefficient of 3 there, see what that gives me. 2 phosphates here, so I'm going to need to make that 2 also. So what that's done, that's going to give me 6 nitrates and 6 ammoniums. Yeah, it works out just fine. I put a 6 right there, squish it in there, and so that equation's balanced. So I'm going to break up this thing. First I need to check and see if I have any solid products or if everything's aqueous. So I first look up the phosphate. Phosphate is down here in the insoluble compound. So phosphates are insoluble unless it's ammonium phosphate or an alkali metal phosphate. Well, barium is not an alkali metal, so this is a solid product. Nitrates and ammonium's always aqueous, so AQ. There we go. All right, so now I can break this apart. I know I have the solid product. So my total ionic equation, there's 3 bariums with a plus 2 charge, plus 6 nitrates with a minus 1 charge. 3 times 2 gives me 6 of those. Plus 6 ammoniums, 6 NH4s with a plus 1 charge, and 2 phosphates, plus 2 PO4s with a -3 charge. Might end up running out of room. Let's see if I can do this. Okay, that's my solid product, so that does not get broken up. Ba3, PO4, 2 stays as a single solid compound there together. And then, let's see if I can fit this on the page. I'm not feeling good about it. 6 ammoniums, plus 1 charge. And then plus, and I'm going to fit my nitrate down here. 6 nitrates with a -1 charge. So I start crossing out things that are the same on each side. Do I have 3 single bariums? No, I do not. Those 3 bariums are bonded to phosphate, so that's a no. 6 nitrates with a -1 charge? Yep, got it right there. 6 ammoniums with a plus 1 charge? There it is. And the 2 phosphates are bonded to barium. So my net ionic equation is going to be 3 bariums with a plus 2 charge plus 2 phosphates with a -3 charge, and that will yield barium phosphate solid. So there's that final net ionic equation. If you need to go back, rewind, watch again, go ahead and do that, and let us know if you need some help.